down. So, for those of you who've just logged on to learn today, you'll see that I've made assessment task 1 available there, and so it's not due for a little while, 7th of September, but it's very quick and easy assignment to produce. It's just about making sure you go through the processes of looking at the services available to sites and knowing who to contact in regards to that. So it covers town planning, so your local council. In fact, I'll open it up and we'll go through it together. So this front page, it's mostly about just conveying the the background information, and it's a place for you to put your name, etc. as well, and make a declaration. And then the rear page, it's about that feedback. But this is the page that we're concerned with, and I'll get that into a better view. Let's no. Is that gonna better? Right. So, imagine you're a building designer intending to build a single-storey dwelling at your current residential address. So, if you live in an apartment or so, just imagine that site as a vacant land without a block of apartments, and somebody's asking you to build a single-storey dwelling on there. Yes, that in some circumstances that may be a bit of a stretch. You know, you live right in the centre of the city, you've got a 10-storey apartment block, etc. But we're thinking about that block of land in its context, and if we were to build a single-storey residential dwelling on that block of land. So we've got to think about the council. So what is the local council, and who is the local council we need to contact in regards to that, and what are their processes in regards to planning? You'll need to collect appropriate documentation outlining the process by which you will need to apply for development approval from your local council. So that will mean going onto the council website. Typically, they've got a drop-down section for planning and building. Go into this drop-down section, and they should have lots of information there. So most councils today have fact sheets. So a list of PDFs, a bunch of fact sheets about just about anything you want to know about planning and building and the planning and building process. But then they'll also have their planning application forms, which may also include a power line declaration form as well. So whenever we're doing new development work, we have to say that it's not happening right next to power lines within a certain distance, and the legislation that governs that is mentioned in the power line declaration form. You'll also have information on fees and possibly information on council turnaround times as well. So some councils provide that. They say, you know, within 4 weeks we will have this assessed, or you'll be notified by the council. So you're required to go onto your local council website and explore all of that, collate that information, fill out the development forms. A lot of development forms are online, but they can also be filled out, and you can print a copy of a non-complete development application form as well. If you have any issues with that, let me know, but it should be straightforward for most councils now. You also to think that your client has asked you, well, what walling material, and you're saying, well, we'll do this in brick veneer, so very standard house. They want to know what brick veneer is, because you've got to assume your client actually knows nothing about building structure and building materials and how they go together. And so they've asked you to describe, well, what is brick veneer, how it is constructed, what are any particular features and details of that brick veneer, and the pros and cons of building in brick veneer. Now, I assume that not all people in this room will know what brick veneer is and how it's constructed. It's, you know, it is, as I say, we have differing building systems around the world, but also differing building systems state to state to state. Yes, brick veneer is one of these forms of construction which is fairly common from state to state, but not necessarily common in other areas of the world. So I'll go through that and give a brief description of what brick veneer is as well. But put simply, for South Australia, it is a very common form of building. If we were to, we can't see much out of these windows here now, but in the surrounding suburbs here, basically, chances are you look at a building, it will be constructed of brick veneer construction. And typically, that brick veneer construction will sit on top of a raft slab as well. The reason we have raft slabs, particularly in South Australia, is because we have very reactive soil that moves around, and a raft slab is basically a large concrete raft type construction with a flat slab and integrated beams in that slab that's able to take the weight of that building and move around on the earth without having any differential movement and any cracking transferred to the building. So I'll draw a quick cross section through a raft slab, just a small section of a cross section. And by the time you've finished studying, you should note this detail very well. So typically within our raft slab, we have some steel as well. So we're cutting through those steel rods. And then we have ligatures joining those together. This piece here is our concrete. And for those of you not so familiar with drafting, that's a brake line. It's a very rough brake line to say. There's more stuff there. There's more going on, but we're looking at this bit. Within our concrete, our slab, so this is what we call our beam. This section here. So this top piece, let's say that's 100 mil, pretty typical. That top 100 mil slab of concrete is attached to beams. Now we have beams that run all the way around the edge, so edge beams, and then we have typically, but not always, well we always have, or almost always have internal beams, but yeah, for residential slab. We have internal beams that may be smaller than the external beams. It depends on what the pressures are and what loads are being imposed. But we have our external beams and then our internal beams. And should be able to find a slab layout for you sometime soon as well. So that's our slab construction with the slab and beams. And then we have this little piece here which is called a rebate. That is typical to brick veneer construction and most forms of veneer construction. What a veneer is an outside skin, an outside coating or something. So you can have a wood veneer on a bench top, for example. It's an outside skin to what is considered the main element. Up above the rebate, we have a piece of timber that runs along the bottom of the wall on top of the slab. That's called a bottom plate. And then we have vertical members of timber. Now we're gonna learn all the names of these as we go through. That one's a stud. But the important thing here is that we understand that timber is the main structural component of the dwelling. That's what holds the roof up. That's actually providing the wall structure and holding the roof as well. And then we have in this plane here, if we look at elevation, we would see bracing happening there as well. So that's to stop the wall frames doing this. So this is what's carrying the load. But as an external skin to this main form of structure, we have bricks and a mortar gap, another brick here, a mortar gap, another brick here, etc. until we, get up to whatever our eaves height is. So 10 mil is your standard for mortar gaps. 76 tall is your standard for bricks, and 110 wide is that's so 110. So 76, 110, and 230 is your standard brick size. That's something I also hope you'll learn fairly soon in this course, because the impacts of the standard size brick does actually have a lot of has a lot of flow-on effects to the design of buildings and the size of windows, size of doors, all these types of things, and we'll go through that later on. But this is our brick veneer, essentially. Well, the whole thing is called brick veneer construction, but that external layer of bricks, provides that veneer of a brick building. Those bricks are also tied back to our timber frames with wall ties that are embedded into the mortar to ensure that brickwork is stabilised by this structural frame. So structural frames are not always timber. In fact, there's been a big move towards using steel for structural frames. Timber provides a little bit more flexibility for us as designers, because we can design these frames in accordance with the timber framing code. That gives us the ability to do that. Steel frames, the design of steel frames is predominantly controlled by the manufacturers of those steel frames. So they have their design systems. So for their studs, so we've got that's our piece of timber like that. But if we were to cut through one of the steel studs, be something like that, and then have some little bits here like this through our stud. So some form, and it would be of a certain thickness, let's say 0.6 or 0.8 mil thick. The manufacturers of those studs, they own that design. They own essentially the intellectual property around the capacity for how those studs work, how they're integrated, all the joining pieces, etc. They can do all the design using their own design software. So they can go, all right, this is the house that you want. We can design that framing system using our stuff. But because timber is a standard, there are standardised procedures for assessing the strength of timber and understanding the strength of timber and the properties of timber. That's all within a framing code with associated tables that convey all of that information. We have that flexibility to be designing these structural elements in accordance with that. So the vast majority of houses you'll see are of this form of construction. It's not the only form of construction, and we'll be going through many other forms of construction. And certainly, if you're wanting to step outside of just the simple standardised status quo of what is done within residential developments, these other aspects or these other methods of building will probably be of interest to you. But it's important that we understand the status quo, that we have, even if you're not particularly interested in brick veneer, that we have that understanding to be able to say, this is what it is, this is how it's constructed. So that's a simple overview. We also, when we design brick veneer, we accept that water will get in there, because water gets into places, and it's an important thing that we ensure that water gets out of there. And so to enable that, we have flashings built into certain sections as well. So that's just an embossed polythene, like a plastic membrane that's fairly rigid, nailed back to our stud and carried under our brickwork, and that X denotes a weep hole in a vertical sense. So this is where our water can come out. So it's designed that our water, if it gets inside our wall, that these ties slope back towards the wall, so that any water gets directed down that inside face of the brickwork, hits our damp-proof course, and goes out our weep holes. We have to ensure that that works. it's much safer to be doing that than try to, well, obviously you do try to stop any ingress of water into a wall, but you have to accept that that water may get in there and that it has to be exited properly. So that's most of our details in regards to brick veneer walling. When it comes to window junctions and window sills and lintels above windows, etc., and our eaves right at the top, there are a bunch of other details. If you can explore those details and include those details, that's fantastic in your report. But this is predominantly your most important one to understand that connection between slab, structural frame, and brickwork. So you're asked to describe that to your client. You may include some pictures, and there may be some fantastic pictures and so on the internet. That's fine. Include those. Do reference them. Do say where you get things from. So include, and there's information on referencing within the Learn page. But what I'm wanting to know is where the information came from when you got it. So for the reader, they can go, all right, that's where it came from. I'm going to go check that out and have a look. And while resources change on the internet, and that resource may change between when you sourced it and when you've produced it, if you've included a date on there, then that covers you for saying, yes, I got this from this source at this date. So yeah, how it is constructed, any particular features and details, and the pros and cons of brick veneer. Why is it the most commonly? Why is it the predominant building system for detached residential dwellings in South Australia? Cheap, yeah, but it might also be cheap because it's so common. Yeah, but yes, it's cheap. It's certainly cheaper than, say, stone. If we were to pay a stonemason to build a house, it would cost a lot of money. There's so many other
So you call it cheaper in the stage, but during the time after 30 years, because many people, when they want to buy the house, they get a mortgage. And
yeah.
That's scary because the work and estate and everything in this house will be, out of order and is in danger, and cost.
Yes. Yep. Yep. So that idea of of permanence and so on, and explore. Yeah. So you're saying, okay, a timber frame is not as strong and as durable as some other methods of building, and that is true. But also, on the flip side to that, we have a lot of movement of soil in South Australia. Things move around like this. Timber, when it's in a structural frame and braced correctly, and then has an external skin on it with brick veneer that has articulation joints in it, etc. So joints along the wall every 6 metres or thereabouts to allow some movement. You can then have movement without structural impact or significant structural impact on the building, and without any visual impact. So without us being able to see that there has been some movement of the structure. If I compare that to building a house out of solid stone, you get several millimetres of movement, it will show through the wall. Whereas there's greater tolerance for movement within these flexible type structures. But the durability, we don't. Yeah. Is it, is it designed to be there for 20 years, 30 years, 40 years? Or what? And
yeah. It's like, this is all about materials, and we're going on about brick veneer.
Yes.
What happens if you just happen to be a greenie and decide you want to do mud brick or hay bale?
Yeah.
Now, the council development plans may allow it, but will you be able to get a mortgage?
Oh, well, that's okay. So you're opening up a very big can of worms there. So I guess a very quick simple answer to that is it depends on your bank, depends on the construction contract that you have in place. So typically councils will certify things, and if they get through the planning consent and the building rules consent and it's certified by council and you have your certificate of occupancy for that building, there should be no reason, and if it complies with the National Construction Code, because it will have to do that in order to satisfy those things, there should be no reason, no special reason particular to that building that the bank should not be able to lend money on. So, yeah, but yes, there are many forms of construction, many motivations for choosing these different forms of construction, and flow-on effects, be that environmental, financial, planning for the future, etc. And these are the things that you will have to understand as building designers. To be able to empathise with your client, to understand what they want, why they want it, and how that can best be achieved within the limitations and constraints that we have. So, not all sites are going to have all of these services. So you have to think about your site, the place that you live, and collect appropriate documentation outlining the processes by which you'll need to apply for development approval from your local council, as well as the following new service connections. Water. Some of you may have mains water at your property, some of you may not. So, we've got if you don't, well then it's a thing about water storage. Possibly, if you're going to go into it, look into bores and wells and the constraints around bores and wells. But many of you will have mains water at the street. Sewage. Typically, if you have mains water at the street, you will also have mains sewer. Not always. There are some places that have mains water without having mains sewer. For those of you that don't have mains sewer, you may look at providing a septic tank and looking at the regulations around on-site wastewater disposal. So that's about how you treat your waste effluent on the site and how that's dispersed into the soil or fed to plants above. So we'll go through the possibly we'll have a chance today to have a look at the on-site wastewater guidelines for South Australia. You may have mains gas, you may have bottled gas. So have a look at that for your site. Most of you will have electricity. Every now and again, there may be somebody in the class who does not have electricity, or an economic supply of electricity to their property, and will have to be off grid. So have battery storage, etc. If you're one of those, please explore that. However, most of you will have electricity on your site, and some of you may have current NBN connection, or NBN rollout has happened within your area, or you're still waiting for NBN rollout, or you might have NBN satellite access based on your address. So look at who we approach for that, how we get those services in place, what sort of forms are required to be filled out. Now, also got to make the point that many of those aspects, many of those aspects have both a retailer and a service provider, and be aware of that. So I can purchase electricity, I can have an electricity retail contract with Origin Energy or AGL or many other energy retailers, but if I have an issue with the supply of that electricity to my property, or if I want to have a new connection of electricity to my property, they are not the people that I speak to in regards to that. There is another body, and we actually have, within South Australia, we have two, and I don't want to give too much away, I need to leave this for you guys to explore, but we have two separate companies that own the network, so the poles and wires. We have one company for all the major infrastructure, all your high tension stuff, the that sort of stuff. And then we have another retailer for this sort of stuff. Oh, and underground, of course. So, sorry, so not retailer. I mean, we have owners of that infrastructure. So that infrastructure is divided up into two. These are the people you'll be interested in for this assignment. Who owns those networks? Who controls that network and makes you pay for that connection and you have to do your application through. So they are distinct from the retailers who sell the electricity and who produce the electricity. Same goes for gas, etc. So explore all of those options. If you have any particular issues in this, let me know. So so some people, with on-site wastewater, etc., may need more confirmation about the limitations, etc., and that's fine. So clearly identify the name of the authority of the service it provides and include completed application forms where appropriate and available. So you should be able to find those application forms. What we don't want is anybody actually applying. Okay. If no applications, was that? Well, if it happens to coincide by all the stars align, yes, do that application and include that application in your assignment. But those who don't want new service connections, please don't apply. If no application forms are available online, in your own words, describe the processes involved in having these services connected and specifically what information you need to provide in terms of the building design. So what information do they need? Also ascertain from the supplier who is responsible for such things as trenching, cable laying, wiring, pipe laying, and any other tasks that may need to be organised by you as the building designer. So we contact our small poles and wires people and we say, oh yeah, we want a connection. They are not necessarily going to come out and provide us with all the infrastructure to the house. Their job will stop at a certain point. They'll say, yeah, we do it here, from here to there, you pay, or you pay this person, or you have to have this particular person or this person with this certification do this thing. That's what we're interested in finding out there. Because if you are a building designer working on behalf of somebody, they're going to have those questions of you. They're going to say, who do I need to get out to get this done? And who do I need to pay? What sort of things is it going? What is it going to cost?
It's water, be very careful.
Right. Yep. What's you?
The hard way. I had the water put onto my block, and before I built the block, okay, someone came along and pinched my water meter.
Right.
Okay, which was really nice. Bent the pipe and put it underground. Now, funnily enough, because I'd had the block for 2 years, I'd mown it many times. And I'd taken a picture of where the thing was. I won't say the company that I had to go through because that's what it was. But they wanted to charge me over $1,000 to put a water meter back on.
Yeah.
And a lot of to and fro, and eventually photographs and a friend of lawyers, they sort of said, okay, yes, we'll put it on. And I've got where they supposedly originally had it and where it actually was. And of course, when we designed the house to go, it's all cool. They then put the meter, the new meter, in the pipe. They moved the pipe virtually 3 foot and put it, as they do, the set distance inside the property line. And left it. And of course, I had to go in and check it. But then the fitter, because they used plastic pipes, hadn't done the connection properly.
Right,
and I'd actually excavated out about 600 tonne of dirt. And there was a big wall. And of course, the pipe was underground. The wall got wet, let go and collapsed onto the building site. Of course, then my builder got very upset. I got very upset. And we then proceeded another round with them. So I suppose to anybody that does that, just be careful if you're controlling that you actually go out and check where it goes, because then I had to fight them to move it 1.5 metres away from where they put it, so that, because all the structural damage had been done to the wall. So
Yeah.
be careful.
Yeah, and certainly in that scenario, it's important to understand who owns what from what point, who is responsible. You know, you got your your water meter, numbers, blah blah blah, pipe in, pipe out. You know, do you own it from here? Do you own it from there onwards? Do you own it from there onwards? You know, property boundary. You know, where do you own? And it's important for you as building designers to understand that. And then who pays for what? Because that, that's where you own it from typically, or who's responsible for what. Yeah. Also, just another quick thing with water, there are various different pipe sizes you can get depending on, and meter sizes and connection sizes you can get depending on your likely water use as well. So explore that. Same sort of thing with power. You can have, or in some places, you'll be restricted to the actual voltage and the supply of power that you can get to that site. So some places will be restricted to just single phase 240 volt power. Other places will have options for more. And it's important to understand that because some of the appliances that you run on your house, like giant air conditioning, although I hope you guys predominantly are smarter than being able to design around relying on massive air conditioners, but you've got giant air conditioners that run off three-phase power that will require that, that 415 volt supply. And you've got to, it's important to understand what is available at your site as well. So speak to this as much as you can about, who is responsible for what, and from where. So that's the first assignment. It's a bit of research, a bit of looking into things, but the actual production of that assignment should not take too long. I think was it September 7th of September that it's due. So 1 month from now. But get cracking on that straight away. That's part of what we're covering in our lecture today. So what we're looking at today are design considerations. So what sort of things do you think about in design? Now, I've got a couple of architects in the room as well, or people who have been through projects and so on, and can bring and engineers, etc., who can bring a lot of information to the table on this. By all means, feel free to add some other things that you think are very important in the design process and what information we are looking for. A few relatively notable buildings there. Does anybody know this building in the bottom left-hand corner?
Old house, Great Ocean Road, Victoria.
Yeah.
Max Pritchard's old house.
Top right.
Top right.
Yeah.
The one over there, I reckon that's up in Stirling.
Could be. I don't know. Don't know that one.
Wouldn't have a clue on the bottom one.
Yeah. No, can't tell.
I've been in Max Pritchard's house.
Yeah. Right. Yeah.
He's a great architect.
Yeah. He does a lot of work. He does. Yeah. A lot of. I've done a bit of work at his. I've never met him, but at his various different sites, I've done work. There was a time, I'd go, oh, it's another Max Pritchard site, right? So he's been very busy. Great South Australian architect. And I guess that's fairly emblematic of his design language. Lightweight structures, structural steel, doing some lovely spanning things, and open areas and lovely connection to the environment.
That's unusual because none of them are brick veneer.
Well, exactly. Yeah, but I say, and that's about so that's about how to say it. You've got a lot of your project builders, off the plan builders, home. Oh no, we don't have homestead anymore, but all your major builders that will say we can sell you this house that's brick veneer on a slab with a tiled roof, and that's predominantly what gets done. And a massive driver of that is what we spoke about last week, are developers' encumbrances. So when the developer divides up a portion of land, they typically place on those individual allotments on the certificate of title an encumbrance to say you can build a house that looks like this, and they give these parameters. Max Pritchard's house would not fit within those parameters. So there are various different mechanisms that drive that, but predominantly the reason developers put those encumbrances on there is because a large portion of the market do want traditional looking houses. They want a traditional looking suburb. But that's typically not, I was going to say it's typically not the market for building designers. It is a massive market for building designers, but also building designers do, I guess, do get a little bit more work when it comes to those individual sites, all the stuff in the hills and the Fluria and outside, and then urban infill sort of stuff where unique individual design is important to the client and important to the site as well. And that's our first thing to think about is our site. What is it? Where is it? What does it look like? So the size of the block. Size of the block can have a massive impact upon what you're building. So you've probably seen, and I've seen it even in so Adelaide is a very sprawling out, broad city. We don't have a great deal of density, and that has also not been encouraged by the town planning as well. But we do have at times tiny little sites in the city. There's even one at I think it's called Broadview. Broadview, just behind the ABC building on northeast. What's that?
Collinswood?
Yes, Collinswood, and there's that suburb behind. I did evaluation of this. Very interesting. It's a 2-story triangular shaped house on a very small allotment within there. It's Broadview. I'm pretty sure that suburb there behind it's called Broadview. You've got your regular rectilineal street pattern, carved blocks, but then it's got some roads that go off on an oblique fashion, and they create tiny little triangular allotments. And yeah, very interesting house. The design of that was dictated by that small triangular allotment. So size of the block can be important, and also in the city, there's a place I looked at. There's a 56 square metre allotment. So 56 square metres, that is not very big. It's slightly larger than what we've got in the room here, but we're still talking about a very, very small site. So size of the block is important. Shape of the block, triangular, long, hammerhead, L-shape, etc. Does everybody know what a hammerhead block is?
Yes.
Yes? Yeah?
Yeah.
Plenty of people seen hammerhead blocks? Those, yeah. Where
One of my friends has at the moment and he doesn't know what he wants to do.
Yeah, and it's not. I don't think it's it's not the best approach to urban planning. I mean, not a great deal of connection to the street and the neighbourhood and the environment, etc. But in some instances, it can produce a lovely amount of privacy and things like that. So it's But that's typically where you've got a lot of Adelaide was carved up into these things, which is known as the quarter acre block. So what's that? A bit over 1,000 square metres. And then people built houses on them. There we go. Standard house on the quarter acre block. You'd have was it Hills hoist out the back and cricket and play cricket out there, whatever. And then council says, all right, well, we don't need minimum site area of 1,000 square metres anymore. We'll allow a site area of 450 square meters, minimum frontage of 10 meters. So they go, oh, well, yeah, we've got 12 meters here of this, you know. What's that?
Here's a driveway.
Yeah, they go, we can cut this piece off and we can sell that piece of land to somebody. So we create separate title. Now, I think one thing that stood out to me as a value was something that I saw again and again and again is people overestimating the amount of money they can make out of such a division. I think it's very important to be aware of that. All of the costs associated in survey, creation of title, and supply of services, etc. Go into that with your eyes open, if you ever touch that sort of thing. But so they think, okay, we can carve off this bit at the back, and we can sell that house as well to somebody who wants a small block of land, and so they make money. And that's what's given rise to a lot of these places, you know, they're called hammerhead allotments, and then, you know, someone builds a house on that there. But that may dictate, you know, size, shape, layout, etc. of your house, because obviously, you know, your entry has to be here. There's, you know, no other choices about that. Slopes or gradients, very important in the design. So, you know, does your council even like retaining walls? Is it in their council-wide objectives to say that they limit retaining walls? Is it within their specific zoning for your property to place a limit on retaining walls? Can you do those? Are there going to be access issues with CFS? They require a road of a certain length, a certain turnaround, and that has to be, you know, maximum slope of 1 metre rise and 3.5 metres of run. Is the slope of the block going to stop that happening?
You have to also think about entry point for a CFS truck. It also has to be 4.5 wide and 8 metres high.
8 metres high, is it?
If you're in a country area with overhanging trees.
Yeah. And an external radius of corners of 12.5 metres. Like, think about that. What's this room? 9 metres wide or something like that. Where, you know, you could go out and that's, you know, yeah. So, you know, and a sloping site, very difficult to achieve. So you have to think about that. Rivers and creeks flowing through. If you have to do on-site wastewater, which, you know, if you're building up in the hills, you don't have sewer connection at your property, you're going to have to do on-site wastewater. There are limitations around how close you can have a septic system to a designated creek, how close that septic soakage area can be to the designated creek, how close the dwelling can be to that designated creek as well. So flick up to here, I'm thinking that's not a designated creek, right? It's about, well, you know the story behind that?
Hey?
You know the story behind that? No. Yeah. So, you know, so we've got it, well, so I said designated creek, I mean designated water course, that's
You've
right.
also got to be careful because they can also classify it as like when underneath flood and stuff like that. Because my property current has got a creek line on it.
Yeah.
And if the creek appears, in fact, it appeared on Tuesday for the first time in 4 years. So, you know, and I've only seen it twice in 23 years.
Yeah.
So,
Yeah.
depends on the rainfall and soakage and all that sort of crap.
Yes. Yeah. And that, and as everything, as as what dictates just about everything is that recorded? Is it a designated water source? So actually they've just had a new name. They're called DEW now, not DEWNR, DEWNR. Now they're just called DEW, Department of Environment and Water. Do they classify that? And are there limitations around that water course? Floodplains are important to understand as well. A project we had to reinstate a building that got burnt out by a fire up at Clare. So the building was down, floor level initially, sort of at street level. Did all the design for the reinstatement, all that sort of stuff, and then council said, there's flooding that happens here, intermediate, in, these periods. You have to pick the building up by a metre, and that is, that's not an easy thing. Well, it can be done. It's just expensive to do that, to go picking up a building by a metre, because then you've got to sort out all of your access and so on as well, and provide disabled access to this building that's just been lifted up by a metre. So important things to understand, and we've got significant floodplain areas north of the city. So we get up to Virginia, sort of from Virginia out to Virginia, Angle Vale, Two Wells area. That's a lot of that is floodplain, where you're required to pick a house up by 400 millimetres off the ground. Can be done with things like waffle pod slabs and so on, and we'll cover that later on. And retaining walls and structures. So retaining walls can be incredibly expensive, and yeah, can that be avoided? Can you elevate the building on piles or adjustable piers, that sort of thing, to minimise that? What are the council what are the council restrictions around cut and fill on a site as well? Some councils, Adelaide Hills, in some of their bits. So when I talk about cut and fill, so this is a hillside. We chop a piece out of here. We dump all the soil there. That's cut and fill. There are issues involved associated with such a thing, because we go build a house on that, and then this soil after time settles a bit more. You get certainly get issues here, and there's you design with concrete piles that go down into there to carry the slab, all that sort of thing. But some councils don't like that. They say we don't, we want to avoid people doing that. You may still be able to apply for such a thing, but it's a non-complying development. It's a little bit more work to get through. Site configuration, factors that affect construction costs: earthworks, retaining walls, piers, underpinning of existing structures, existing buildings, adjoining buildings, etc. When we are doing work that is at high risk of damaging other structures nearby, we have to, or it's good practice to get a dilapidation report in place. And so there are consultants you can employ to get a dilapidation report done. That is basically a report produced by somebody who's gone along, and so let's say this is our adjoining building here. They will go along and they'll do a thorough assessment of that building, including the footpath and anything around the site there that would give indication of pre-existing conditions. So they will look for, okay, well, we've got this control joint here in this brickwork. It's 10 millimetres at the bottom, 14 millimetres at the top. That's indicating some sort of movement of that slab, or stresses on that slab. And they'll look for all sorts of things, any little cracking, any of these sorts of things, because what can happen is, if we're working on this site and we're using pile drivers or something to ram stuff down into the ground, it causes disturbance. What may happen is that some damage becomes evident in this building, and they go, well, we're going to sue you guys for the rectification of the damage to this building because of the work you're doing on your site. What you've done has influenced us. If you have that thorough dilapidation report in place beforehand, you provide yourself essentially the best level of cover against any sort of vexatious claims or any well motivated claims. But it means that the liability for you and rectification of that is limited to what is required, because already recorded that there were existing stresses on that building, or there were pre-existing conditions which caused that. Did anybody feel the earthquake last night?
No.
No?
Yeah,
No?
and last night.
Yeah, we felt it. Came through the hills. It's like.
I don't think we would have felt it in the car, but
You're trying.
as soon as 8:30 came, we were on the ABC and straight within seconds of the earthquake happening with the reports coming.
It was 3.2 out of.
Yeah, 3.2.
Yeah.
Which, you know, I think the last one we had, I missed the third last one, the second last one. That just felt like one of the typical brickish trucks that would come down the road.
Yeah.
So I'll tell you what it moved in at. And actually, yeah, for I at Paramount, it was over at Mount Columbus. And I'd actually only just finished painting on my house, so I'd filled in all the cracks on the front of the house because I've got a fibre just type thing. And literally right above the front door, there's a crack now.
Tons of crap.
And like we were at home and we felt it, and it was sort of like, guys, and like you say, it felt like a truck coming down the street that was going to fly and come through the front door.
Yeah.
It was that loud, and we got out.
My wife just said it was cloud.
Yeah. Well, and that's what it sounded like. And when I used to work doing the repair and reinstatement stuff, yes, we get these tiny little earthquakes in South Australia. We haven't had have had any significant disaster and any significant earthquake. But you following on from that, you get a flurry of jobs that come in for earthquake damage, and a great contributor to that are pre-existing conditions. So where you've got soil which has subsided or shrunk or soil which is lifted up, putting stresses on a building, and then you get a little bit of movement. Things.
It's a good classic example at the moment, and it's such an interesting thing to watch, is the m&mdip Hotel.
Yes.
Because that's got some huge timbers, webbing straps, they've got pylons trying to hold it up. It's like if someone's just packed a box of something, and you know, it's got, you can see the cracks, and the cracks are moving not open as well, but away from each other. And it would be, you know, if you're interested, that would be the classic example. It is just brilliant to just see how it changes every day.
Yeah, right. So that's why the scaffolding goes up. And then, that's why they keep it there to hold the building.
No one's put their sign up saying that they're doing the actual
doing the work.
repairs, because if it falls over, they finally did board up the chimney. I thought that was the first thing that would go down.
So when we're doing some work on site, it's important to get a record of any of that damage, or even if there's some damage to a building, some render has been knocked off here or whatever, and the owners didn't know about that, and they say, oh, these dudes with the skid steer, they banged into our wall and took this render off. At least if you've got that dilapidation report in place, you can go, nah, that render was broken already. It was, wasn't the fellas driving the machine, it was somebody else. Well, pre-existing. So also, although it's not just, limiting liability while you have a look at existing buildings, adjoining structures, etc. So for existing buildings, maybe we don't want to keep that building. Maybe the highest and best use no longer involves that building. We have to remove that building. There are costs in demolition, and costs can be fairly significant. But actually, I used to think asbestos removal was really expensive, and then I actually went through the process of getting a quote for asbestos removal. It wasn't actually as onerous as I thought, but be aware, you got to pay for it, right? So it's still in thousands of dollars. But demolition of buildings, $10,000, $15,000, $20,000, depending on the building, depending on the structure, and what materials can be reused, whether there's any materials in there that's worth anything to anybody, or whether it all has to be disposed of. So you've got to think about that, the existing structures, or can those existing structures be reused and repurposed in a good way? What a fantastic opportunity for mass recycling in one thing. You know, beware of the costs involved in that type of work as well, because typically it's far more expensive and time consuming to be working on existing buildings and old buildings where corners aren't straight and so on than it is on new construction. But it's of a consideration. But also adjoining buildings, whether it's blocking our winter sun, whether it's channeling winds in certain fashions, whether those windows are looking directly onto, you know, where you plan to do an outdoor spa. We've got to think about the impact of, you know, what other buildings are around, how they're used. You know, maybe it's a crash repair site and they're doing spray painting all the time and they're sending it out through their ventilation fans. You might want to look at another site, or you know, so you've got to think about adjoining buildings and adjoining uses and what they do. Very important, street and lot number. Got to avoid building on the wrong lot. I haven't been involved in any buildings on the wrong allotment of land. You have.
Yeah.
Conveyance, that's what that's for.
Actually, my land house, I live in land house and it's new one, and they swapped the next door number and mine, so I couldn't get any electricity fee or something.
Yeah, so
I have a lot of problem with the last number.
Right. So they swapped ownership of the title.
Yeah, the owner was very upset.
Yeah.
But now we figure out, but about 2 months ago, it's hard to.
Yeah.
You've got to be careful with some real estate agents when they do multiple.
Yeah.
It's too. My daughter went to buy a house, I'll rephrase that. Thought she bought a block of land at Maskins Beach, but it was a subdivision of a block into 3. And the real estate agent put this for sale sign on the biggest block, which is what she signed up for. She signed up to have a house built, the builder, everything. It finally got to conveyancer. On the day of conveyance transfer of funds, the conveyancer said, not that block, it's the block next door.
Well, that's the conveyancer doing their job, isn't it?
That's the conveyancer doing the job. So a conveyancer is very important. And then, of course, the real estate agent got a very good phone call from me, and we ended up buying the block that she wanted, that was for sale, but we got a greatly reduced price.
Yeah.
So.
Yeah. And fair enough as well.
Yeah. It's easy to happen because in a lot of rows or blocks, they're all the same size, so the title sheet looks the same, you know, the same setup, but the lot number sign's fallen over and someone puts it back in the wrong place.
Well, they go A, B, C.
Yeah.
Because they're all 59.
Yeah, it's my house is 7 and 17, 17A and 17B. So the almost.
Yeah. And I almost got caught out over in Kangaroo Island at bush blocks. So there's a kind of residential subdivision that happened at a place called Huon Bay, which is, you know, beautiful spot. That out back of nowhere, it's fairly remote, good place to get to. But yeah, a lot of these smaller allotments, 1,000 square meters or thereabouts, you know, with just lots of bushland, carved up in the 1970s, I think. So survey pegs, some of them are there, some of them are not. Ones that are there, you know, might have been eaten by termites. There's not a lot of indication. And yeah, a friend of mine thought they were buying a block, actually bought the one next door, same sort of thing. But that wasn't discovered until after all the conveyance and everything. It was till I went there with a friend to do the site survey, and we were trying to work out actually. So where does this block start? And he measured from various points and go, actually, it's this one here, and you've got that confirmation that actually that was the block. Turned out well. But you know, it can so easily happen that confusion exists, and so very important.
Yeah, when should as building planners, when should a building planner actually decide to have a block survey or site survey?
Well, that's an economic decision. So, and it's all very case specific. So site surveys are not cheap, and it varies per site and what's actually involved in doing that site survey. And okay, so the best thing is, okay, you've got to get site surveys done before you start planning anything, but then that's not done in the vast majority of cases, because in many cases, a lot of that information is easy to ascertain. And then if you're doing that site survey, paying for that site survey of all these places, it's not money used efficiently. But to be safe, yes, site survey should happen early. So it's an economic decision about that, and you approach that decision on a case-by-case basis. I took you all through certificates of title last week, significantly, didn't I? Well, suitably. So, got our certificate of title, our registered proprietor. So, who owns the land? Is it the grandchild who wants to build a house, waiting for the grandparents to pass on what not? Important thing to understand who actually owns the land and whether they have the right for doing that work. Description of the land, so that's the legal description. It says it is allotment here in this particular plan, these particular sizes, etc. Any easements, so we're all comfortable with easements. Yep. Encumbrances, so all comfortable with what an encumbrance is. And you'll learn more about easements and encumbrances over time. We could talk to calcium home about the various different types and whatnot. Liens, so financial debt against the property. So who is it mortgaged to, or who has an additional interest, a financial interest in that property. And plan of the allotment, boundaries and angles, lot number, easements, and orientation. One thing I'm not sure we covered. Oh, we did talk about zoning last week, didn't we? Residential zones. Well, first, yeah. Are we comfortable with that, or do we want to speak more about zoning? Yeah. So our zoning, all of our urban area, all the land within South Australia comes under one particular council zone or another. That dictates what we can do on that piece of land, and that's included within the development plan. With our services, we have to locate existing services. Think about gas, sewer, telephone, underground power, stormwater, grey water. One handy resource. So, did I show you this last week, the SA Map Viewer? So, yeah. With that, we can, it's on roads already, go data sets, infrastructure and utilities, where's our, go water main, turn that one on. There we go. We can see who's got mains water there, and where that mains water is running. So a select, actually that's not a residential property. I think that is actually that is SA Water facilities there. And so none of these places up here have mains water. Well, actually maybe these ones on Range Road have mains water connection. to those. But beyond that, you know, people have their various different bores and rainwater tanks and all that sort of stuff. Down here, you know, mains water everywhere. So we can use the map viewer for locating some of the existing services. Other existing services, you might have to look on site, see what's on site, see what the names have for gas meters and things like that, or you contact those service providers as well, or from their websites they also show the network of those. So it's a combination of things to find out about those. Stormwater is important. One, to think about what we're going to do with that stormwater. So the water that runs off the roof of the dwelling, and or any impact of our development on how the water then moves across the land. So we can't be entirely responsible for all the water that falls on the property and how it's dealt with. If we did nothing to that site, water's falling on that property and going onto a neighbouring site, it's got nothing to do with us. But as soon as we start digging in, you know, site features or something like that and causing water to go in a certain direction, then we are responsible. As soon as we put up a roof and have downpipes and water comes out of those downpipes, we're responsible for that because we've altered the course of that water. What councils like is getting that water to the street. There are, I guess, various different permutations to that, but they want to ensure that that water coming off of your roof is not going to the neighbours. And so think about that. You know, great. It's a bit of a small thing, but let's say, you know, it's hard for some people to see. Well, let's put our street here. And that's our site, and our street is at this level. Our gutters are here, like that. Typically, what I've seen a lot of issues with are sumps. So there are quite a few situations whereby, you know, our street is up here, it's higher than our gutters, and, you know, these downpipes go into, you know, a 600 by 600 hole in the ground with a grate over top and a submersible pump inside that, and then that water is pumped up to the street. Submersible pumps, being electrical equipment, will fail one day. You know, maybe not tomorrow, maybe not next week, but they will fail one day. And it is a bit of a risky thing with these sumps that, you know, it will fail in a large rainfall event and you won't know about it until there's been some detrimental damage to the neighbours. So I'm not a great fan of sumps and doing that. Possibly, you know, a better way to approach such a thing is to have a tank that serves as the sump, and then you have some overflow feature from that to, if your pump fails, well then your overflow, you know, is going to be a minimised impact, and that way you get some time to see, okay, that tank, you know, filled up in the last rainfall event and it's not clearing out. Is there an issue with our pump? Gives you, yeah. Anyhow, so
the same with the sewers as well. Like if you are doing a development,
yeah,
this is, and the particular block of land heavily sloped.
yeah,
They don't, because it's near a lake. They don't have septic tanks because of into the lake, and they've got a pump the waste out to road level.
yeah.
And that's like a 9 metre pumping job. How do you?
Yeah. Typically, so those systems, and typically you buy a grey water system or a waste recycle system or an on-site wastewater recycling system that has, typically they have designed in them alarms that go off when things are not working. you know, you might have that little alarm thing in your laundry or so in a less conspicuous place. But when something's gone wrong with that, it says, you know, it sends off this alarm, I need to be checked and serviced, etc. And there's also the requirement of those on-site wastewater facilities need to be checked every 3 months, so quarterly. So the people who produce those, typically they get the contracts for doing it. Now you can actually get certification for being one of these waste treatment inspectors. Like TAFE does it here, and you know, I've looked into it myself because to get somebody out costs about $150 a time. So, you know, 4 times a year, that's $600 a year you're spending for somebody to come out and go, yeah, it's working, and chuck the tablets in. I'm saying, yeah, yes, they do much more than that, but yeah, it's, you know, it's about checking that system, etc. But possibly there's a great deal of money to be saved there or made there by doing that sort of work. But there is that requirement for those systems to be checked. There's a big, I think a wide gulf between new rules about what's required today for new systems and anything you install today, and what has happened in the past. And you've got all of this existing infrastructure. So these ones near the lake.
It's
may not
down on High Island.
High Island, yeah.
Designing the house.
Yeah.
It's one of the little things that the owner is sort of, it's not something, the house is a 3-story house, and it's something that's going to be built next year, so potentially by the time we finish this, I'll be able to sign off on things. But
yeah,
we've already got a concept thing in, and there's an existing house that we're going to bulldoze.
Mm-hmm.
And the current situation is the septic is only probably 3 metres, maybe 2.5, from road line where it gets pumped currently.
Yes.
But
yeah.
because of the redesign of the house with 3 stories and everything else,
You're going to have to shift that septic system.
it's going to be shifted down below the in-ground swimming pool.
Yeah.
And down the bottom of the block. So you've got a big pump to take it up the top. It's just one of those things. I found out, okay, that's got to be done. Okay. It's okay. Recycled payment. It's just.
Yeah. So you know, you may be able to update that grey water. I know you've probably been through all that, whatever, but you can't. But there are pumps that do higher pressure and higher volumes as well, because you've got various different design of these systems. Some of the dispersal systems are what's called a pressure dose system, where you have all these underground tubes. You actually have to provide a fair bit of pressure in those tubes to disperse the weight into clay soils and things like that as well. So there's, probably, I dare say there's certainly options for that. But these modern systems have alarms to say that there's something going wrong, and but there is that thing. So and you've probably been through already, but SA Health on-site wastewater guidelines.
Not in detail yet, because we've only just started concept design.
Yeah. So have a good look at SA Health on-site wastewater guidelines and the appendices there. They've got various different design examples. I don't think there's anything that touches on that, on the providing head pressure to sewer main. But anyhow, but it's good, good to have a look at those things for that additional information. And there are consultants you can employ to design those things, and council may require that as well. They'll say you need to have this one designed by a wastewater engineer. But it's a good thing to know before you go and chat with wastewater engineer, and before you go thinking about this is our design, and then you find out, oh yeah, we can't do that because of this. So stormwater, grey water, telephone. So a lot of people don't particularly have landlines anymore, but that system's sort of been taken over by broadband. and a lot of that infrastructure being used for that. So I'd supplant that with NBN. So that's our certificate title. We've been through those, I think, sufficiently. We'll keep moving on. Well, we didn't see one this large last week. That's a survey plan, so a survey plan image showing an area. But then it shows some details here about easements and corner cut-offs, whatnot, that can't so easily be shown on this plan. So it references certain areas and shows those aspects in detail. Another one. So yeah, just before the lecture, I was just looking to see if I could actually find that exact property on SA Map Viewer. To look at that, I think I found that property on SA Map Viewer.
Looks like my property actually. My boundaries are just about the same. So
Right.
believe it or not.
Northeast Road and Range Road, South Houghton. Yeah, I couldn't find any boundaries that looked exactly the same as that actually, but I think it might be here, and that easement may be to do with that SA water main going through there. Looking at that on satellite view. Oh. Where were we? It's not important. Oh, there we are. We've got a pipeline running through here. Well, there we go. That's what I was thinking of. So zooming in on that, from here you go, oh, there's a big water pipe there. So, and that seemed to correspond fairly well with that. But anyhow, we won't bore ourselves with that. So easements for whatever, and we have to determine what those easements are for. More survey plan images, so it's a slightly older survey plan image. Once again, shows the detail here for corner cutoff at allotment 1. We're going to have to, with our site, we're going to have to know what sort of soil we're building on. So we get, yeah, I'd say that looks like an American picture, and that's not your standard. So typically you get your soil sampled. It's a hollow core drill tube that they're just on the back of a 4-wheel drive, like a Land Cruiser type setup with a hydraulic drive driven by that. So much significantly smaller units than this, and they will. And it all depends on your soil and what information the engineer wants to know. But they'll take 3 or 4 samples at your site where you're looking to build a house, and maybe one where you're looking to do the on-site wastewater. And if it's good soil sampler and engineer, they'll probably go down to 3.5, 4 meters depth. Or but there are companies that go, all right, we'll do 2 meters, 2 meters, 2 meters, and we'll do one of them at 3 meters. So, but that takes out a column of soil. Do we have a column of soil to show? No, we don't. So just basically, what you end up with is this long cylinder of soil. So the soil sampler will pull their stainless steel tubes out and tap them, and tap the soil into boxes, and then the engineer who's producing these bore logs can go along and look at that soil and go, this is the type of soil it is, and they'll classify it. So they'll classify it into various different classifications of that soil. But the thing that is of major concern to us here in Adelaide is how much that soil will react to moisture, how expansive that soil is. If it's this really solid green clay, then it's that's very, very reactive, and we get our reactivity expressed in Y values for that. Before going outside, or before meeting with a client, before any of these things that requires you to step out of the office for a particular event, go very well prepared. So if we go to site, what we in designing a house, yes, possibly, you know, we may go to site a lot more. There are some people, and I saw it on Grand Design's show last week, where people were saying, we lived on site for a year before we, you know, decided what to build here. You know, getting to know the site is incredibly important, and it may happen over time, but also visits to site may be rare, and you may have to gather a lot of information on that day, and it may be a bit embarrassing for you to be phoning up the client and going, oh yeah, I didn't get this information, or might be a bit of a waste or expensive in time for you to continuously drop out to that site to get information you didn't get before. So get a checklist prepared before site inspection. Conduct a detailed survey of the site, locate features on the site, so significant trees. Well, we should be taking notes of any trees actually. So what trees exist there, what services are, sewer, fencing, buildings and other structures, rivers and creeks, obviously, potholes and mounds. Any other sort of things we should be looking for on site, people can think of? I might look for indication of contamination and pesticide use and so on. Like for, you know, there's, you know, truck parts and all that sort of stuff that are 50 years old, sort of half poking out of the soil. That might be a consideration.
White ant mounds.
What's that?
White ant mounds.
White ant mounds. Yeah. Yeah, but white ants can also travel a long way underground as well. Anything else? So, yeah. Oh, we've got buildings and other structures, but certainly neighbouring buildings as well. I'd check access to the site, road access, and so on, and all your services. Whether it's a busy road, it's probably important to have established your zoning and your zoning constraints before visiting a site as well. But then there might be a bunch of other site-specific things to think about. And a lot of this research can be done prior to going. There's so much research that can be done prior to going to a site as well. So for all of your online resources to gain all that information, I've previously drawn up indicative house plans straight from Google Earth. I get the image, put it into CAD, draw it up, like scale it up to some known dimensions, and then draw up these things. And I've been about 100 millimeters out. I mean, that's, you know, you can, maybe that's a fluke, I don't know, but you can actually get some relatively detailed stuff before you even go to site and do any measuring up. So
do people actually do this before they buy the block? Or
some people do. It
can get very expensive.
Yeah, but yes, some people do all that investigation. I'm surprised at them, at how some people make such massive financial decisions without doing a lot of this investigation. What's that?
I say it's emotion.
Yeah, well, yeah, I guess, yeah, certainly many emotional drivers and yeah, all these sorts of things. I guess you guys are very fortunate in that you have access to, you know where to get a lot of this information, or you will know where to get a lot of this information and what to look for, and for doing a lot of that assessment prior to the purchase of a block. So you guys certainly got that head start. It is fairly rare though that people will engage a designer or an architect prior to purchasing a block. They don't, you know, it's not normally done. But some people do employ, you know, like buyer's agents. So you've got your real estate agents who work on behalf of the vendor. There are also agents who work on behalf of the buyer. Not many people go through buyer's agents, but they do exist. That they can help you in your search for things and act as an advocate for you, or even bid for you at auction, all that sort of thing. So those people exist, and also it's also fairly common to get a building survey done when buying an existing property as well. But yeah, it is all each to their own. But yes, it can you're right, it can be very expensive. Allotment survey, all these sorts of things. Yes, and sometimes the initial expense is not worth you weigh up that risk, of okay, how risky is that, or how much do we need to know this, how much do we have to attenuate that risk, and what is it worth? So survey and prepare plan. Take a series of spot levels for producing the contour plan. I haven't really kept up to date with survey stuff. I use survey stuff a lot for working out how buildings are twisting and so on, for taking all these levels around a building, so follow a brick course around and then put it into an Excel spreadsheet to produce a code to chuck into CAD to produce a 3D of what that building is doing. Done plenty of that. What I haven't done for a long time is site plans and contour plans. So I imagine things have moved on since then.
Just employ a surveyor just to go and give you that as and just on build the client.
You may, yeah, certainly.
Trying to do it yourself and take the liability of that.
Yes, I guess that is a good point. Yeah.
Having just a few years ago done that for the project I'm doing.
Yeah.
Okay. I was very lucky that my surveyor happens to be a very sort of friend and it cost me a few slaps.
Yeah.
But the scenario, because it was a very irregular plot, had I done all what you've just said now, I may not have even tackled the project that I'm in.
Yeah.
Because I would have found out that highly reactive soil, really I'm going to have to do a lot of excavation because of the cut and fill thing.
Yes.
All those sort of things, you wouldn't have said, okay, from the initial purchase of a block at 200,000, to spend another 150,000 before I can even start building. Pretty crazy shit.
Yes. Yeah. And that's something that you pick up through that thing. But it's also one of those things. It's about making that judgment of, okay, we can do all that initial investigation, but are those things going to be really expensive? What risk is that offsetting, and what is that worth? And so I completely understand, and I've done it as well. I've bought a property which was a reactive site. I knew that soil in that area was fairly reactive, but I got a surprise after buying the site and then getting soil samples done. I had Y values around 115, so that's right up there. I guess diligent thing is to get those soil samples done beforehand, but then you're not going to go doing that on like a dozen sites or whatever before purchasing, typically. But that's a very good point that you made, Doug, though, in regards to limiting your liability as a designer and outsourcing work where you can. So for those so for site surveys and so on, and for contour plans and whatnot, yes, if you can get somebody who has all the right equipment and so on to do that, and then we'll take that liability, that is good and important. So used to determine design levels, bench level, finished floor level, retaining wall design, etc. So here's various different survey plan images. So detailed survey of this allotment. Can't see who prepared that one. So Matson and Martin. I don't know if that's a local one or not. Also have to think about material deliveries and access for trades. How's the stuff going to get onto site? Are there, will we need a crane? Can we get a crane onto site? I've seen, probably everybody's seen crazy stuff on television about helicoptering stuff in and all these sorts of stuff. Maybe it's good at the design stage to think about cheaper options or limit what's designed based on your access to a site and so on.
Yeah, this brings up the hammerhead block. We had one around the corner, and when you're trying to back a semi on a narrow driveway, I tell you, you haven't got a very happy driver.
No, no.
And obviously they must put costs on for delivery if it's going to be a difficult delivery.
Yeah, I guess so. I haven't encountered that. I've had costs because of location away from city, all that sort of stuff. You go, okay, we've got this 200 k's to drive or something. We'll charge you X amount for that, or you're in that zone. Yeah, I haven't encountered that, but I dare say that certainly exists. Yeah, with deliveries, particularly certainly things like concrete and whatnot. When it's a difficult site.
Too much, do they?
What's that?
They don't weigh too much. A concrete truck full of concrete. Nice weather for them to be backing up a hammerhead.
Yeah.
Usually they'll pump. I mean.
Yeah.
The concrete that I've had.
Yeah, well,
so
that brings
far,
in the extra cost.
They put the big booms and pump, and I suppose he had to pump virtually across that.
Yeah.
To pump.
Yeah.
And it just a big arm.
Yeah.
I was amazed when I was down there watching the pump.
Yeah, and that is a much nicer way of placing concrete. Like, so you've got concrete pumps, which are the pipes on the ground. You've got this metal hook, and you move it around like this. Yeah. When it on the boom, that's very easy, more significantly easier job for the people placing the concrete.
That's becoming
and
more commonplace. So
it is, yeah, certainly, yeah.
I've seen them just pumping from the street to the back of the block. In the old days, it was the old little guy with the wheelbarrow.
I didn't get a thing of that, but I was pretty amazed. I just pulled up on the road and put the boom out.
So certainly concrete pumps opened up things, and cranes getting cheaper as well. They're still very expensive. What's that? Yeah. $500 an hour for a 100-ton crane. So it's still very expensive, but it's getting into the realm of possibility. But very important thing to think about, how you're going to get stuff there. Adjoining properties, record the building on the adjoining properties and the boundary. Prepare a dilapidation report. There we go. Type of fencing, steel, masonry. Services, we've covered that. So, main design principles, building design, types of materials. So, is it in a bushfire zone? Is that going to tell you what type of material? Does your client want a particular aesthetic, or is there a certain aesthetic which is in the area, and how do we meet that? Is there like a local vernacular? Is there like talk about that place at Vivon Bay earlier on? Down there's lots of stone houses built of local limestone. It's a look that's in that particular spot. Is that going to be a good idea to follow? Energy efficiency of dwelling and appliances, and how the occupants behave, what they actually want to do with the house. So how they live. So the building design has to comply with building regulations, National Construction Code.
Energy efficiency of the dwelling, doesn't that go by the code for the area? Like most of Adelaide's 5, but the minute you go past the hills face south, it's 6. So then you've got to design for that climate zone, or somehow meet it with your energy efficiency rating.
So and that's a relatively recent introduction into the National Construction Code. Are those basic standards around energy efficiency and the design of buildings to ensure that they don't require significant inputs of energy to regulate the temperature. And so although Australia has been, National Construction Code has had and the BCA before it has had a map of Australia divided up into climate zones for a very long time, because there are many other considerations with that. But yes, down here on the plain in Adelaide, we're climate zone 5. In the hills, Victoria Peninsula, etc., it's climate zone 6. Areas of Tasmania, climate zone 7. Go up north, we've got climate zone 2 and 3. And so we have all these different zones because temperatures and winds and well, climate does different things in these areas. Yes, it is a very general thing, but it will dictate the type of windows you can have, the type of insulation you need. For example, in climate zone 5, if I've got a light coloured roof, the insulation I need in my roof is R4.1. If I do exactly that same house, but out of, I don't know, I think it's climate zone 6, but let's go to climate zone 6. I'll need I think it's, I'm not sure what I need actually, but let's say R5.1. What's that?
I've got black, well, it's going to be a black roof, and I'm down the hill.
Yeah.
It's going to be R7.
R7, yeah.
And that's only part of my.
Yeah.
I've actually got another special phase change installation we can put into the roof, so I failed energy report.
Right, yes. And yes.
It's stupid.
Yes, and that's essentially what makes a lot of these decisions. Yes, okay, it sets the base standard of what you need to achieve for that dwelling, but that is assessed by energy raters who use software to determine how that house will perform in that environment and that location. Not all of it is exact, and yeah, and yeah. No, we won't go explore that. But that's how it's dictated. That's how these requirements to meet this 6-star energy rating happen. One of the things that plays into that is orientation of the building, solar access. Do we have good access in terms of getting lots of sun in there during winter time, or do we have any bad access in terms of getting sun in there in summertime, or sun directly from a westerly direction or easterly direction, providing heat or excessive levels of heat when we don't want it? Yes, all sorts of things get through building rules consent, and that's get a 6-star energy rating put on them. That I sometimes think, how on earth did that happen? But orientation is a very important factor in that, and how that works with the shading. But there are, I guess, essentially it is important to understand the inputs into determining that 6-star rating, so you can do the best by your client in terms of their budget and getting things to happen. But also, the concepts go much further than that. That these are only computer programs that don't thoroughly assess your particular site as well as you can do as a designer who is able to look at many more things. It's sort of that nexus between, machine learning, what a machine can work out, and how much the human mind and how much we can be site specific. So there's still a lot of value in understanding all of these aspects beyond just meeting the star rating. So no or fewer windows south, east, west. So yeah, you want shade in sometime only. Slab on the ground is a really good thing to provide thermal mass if your sun is shining in there correctly. So if you get your solar orientation right, well then thermal mass is a fantastic friend. If you get your solar orientation wrong and you're getting sun in there in summertime and none in wintertime, well then thermal mass can be a curse. Thermal mass, that's just the ability of certain materials to take up heat when there's heat being applied to it, and then give that heat out at a later date, or at a later time. So a good example of that is wintertime. You get lots of sun streaming into your house because you've got your windows facing north and the sun is low in the sky during wintertime. It follows this sort of fairly low arc. In summertime, very high arc. Sorry, in wintertime, very low arc. Summertime, very high arc. Shines in during wintertime, and all of that warmth gets absorbed by your concrete slab. And the sun goes down, things start to get cooler, but inside your house it's kept nice and warm because all this heat is coming off that concrete slab. So, and various other ways of achieving thermal mass within a building. So some solid masonry, even things like hollow masonry blocks, Besser blocks, filled with sand. That's a very low embodied energy, and that's another thing. So embodied energy, the amount of energy required to produce those building materials and get them to site as well. Cross-flow ventilation is important. So that works, and that's very site specific. So it's thinking about gully breezes and where breezes are coming from at what time of the day and direction and so on. Yes, we can go onto Willy Weather and get a windrose for that location. We're running out of bits. I won't be able to take you through windroses and how to look at all those. But yes, we can get some general climatic things in relation to what the wind does at that site, but also some great site knowledge and built up over time. This can also be very important for thinking about getting those breezes through the house, enabling those breezes to come through the house by your placement of windows and passages and things like that. Roof walls insulated, light colours of roof and walls. So yeah, black roof, bumps up your requirements for insulation because you get sun shining on that. Black absorbs heat, it doesn't reflect a lot, we get more brought in. And that black colour, put that into the computer software, make it go crazy. Well, that's a bit of an exaggeration, but light colours work best, but then there's that tussle between what does the council want, etc. Like yes, I think galv roofs I think they're a beautiful thing, but what's that?
I would love to go.
Yeah, but councils don't think they're a beautiful thing. Some councils don't think they're a beautiful thing. Or in certain areas as well. Just as I guess showing an ideal design. So our garage to the west. So this bit of the house can get hot by that evening sun, but keeps the rest of it shaded. We have our kitchen northeastern corner. So in the morning, get sunlight into the kitchen there. You can sit at the bench, basking in sunlight in the winter time, and it's lovely. All of our bedrooms on the southern side of the building, where typically we want those rooms to be cooler. And that is client specific. Personally, yes, I do like a cooler bedroom, sleep better. And that might be an important question to ask your client. But then your living areas, etc., to the north, where you want that winter warmth. That's more on that solar access. I think we understand that fairly well. And ventilation, how that can be achieved. So things like these clear story windows can serve several purposes. That's facing north. Your winter sun can come in through that clear story window, heating up your building fabric, but it can also be used for ventilating the house by having that hot air rise and the hot air being taken out and drawing cool air in. For those couple of you from Iran, I've spent some time in Iran as well and visited Yazd, and so yeah. But some amazing architecture there. That in this regard, buildings which are hundreds, if not thousands of years old, that have these big mud brick cooling towers that draw in wind from the windward side, drive it under the house, comes up through grates, and then sucks out the hot air from the top of the house on the leeward side. So very slight breeze, air conditions the house with no input of energy at all. Some amazing design stuff that possibly we could use in our very dry, hot climate in South Australia. So but we can, yes, such a structure might be expensive to build, but we can adopt those same sort of principles within our house design as well, thinking about being site specific. Deciduous trees to the north and evergreen trees to the west, so shading buildings permanently to the western side. So yeah, some more things in regards to solar access. and ventilation. Some diagrams of some skillion roofs with significant shading to allow that winter sun in winter time, but provide shade in summertime. Spoke earlier about climate zones in South Australia. So this is the old climate zone map. From my knowledge, it hasn't really changed since this image, but of course, the up-to-date information is always in the National Construction Code. On the flat here, the plain, we're climate zone 5. Go into the hills, you get into climate zone 6. It's cooler. So, yeah, we can't read that, but I think it's known as warm temperate. Don't take it for granted on that, but yeah, we have a little bit more agreeable climate down here in climate zone 5 than in climate zone 6. Things are a bit cooler in winter time. Has anybody been to Cooper Pedy? Yeah, I thought you might have. Yeah, yeah, very interesting place. Look, yeah, it's a long way to drive. Don't book it in as a weekend event. But that's drive up to what Whyalla and whatnot, and then keep Port Augusta, and then just keep going. You come to this little mining town where they mine opals. There's a whole lot of underground houses there. It's it's sort of yeah, it's like the house, like the town that Mad Max built or so. But that is a rarity for us in Australia to have these houses underground, caves, etc. But that is actually quite, well, I was going to say it's quite common, but you do get that around the world a lot. You probably areas of Iran that there's significant cave dwellings. Cappadocia in Turkey is one of those places that's famous for it, where people have hewn houses into the limestone there for living. But yeah, it's actually it's probably a bit more common than what many people would realise. But you get, how I say it, there's a lot of comfort, particularly in dry, hot areas from living underground like that. Thermal performance of various different materials, and we have to see how we're going for time there. So I mentioned thermal mass earlier. We've got a table here showing the thermal mass per cubic metre of a material. So that relates to how many kilojoules of energy that material can take up and then put out at another time. So the capacity of these materials for their thermal mass is different. And then we have a graph down here showing the temperature stability of various different walling systems. So this solid line here, the one that's most variable, well, that's just the outdoor temperature. So that's our baseline for which we can compare. This one that's fairly reactive is a light timber framed building. This fella here, well, actually, oh no, sorry, that's reverse brick veneer. Without the bricks on there, then it's light timber frame. Then heavy building with external insulation, so we've got thermal mass and then insulation on the outside of that thermal mass, be that like polystyrene cladding which is rendered or so. And then this line here, which is almost invariable, is heavy building set into and partially covered with earth. We have a very famous earth building, what do we call it? Earth berm building in Australia. Can anybody think of what that is? What's that? No, not round earth, like earth berm as in built into the earth. So you dig out some earth, build a building in there, cover it mostly. Yeah, Parliament House. So probably our most known building in Australia is actually one of those buildings set into the earth. But then there's various different examples of that through the hills as well. People who've done that. But it takes advantage of that regular temperature of the earth and the overriding thermal mass that earth has. But we can think about the thermal mass of our various different materials there as well. And this one here is called brick veneer. Now we spoke about, that's reverse brick veneer. We spoke about brick veneer earlier. Our timber frame and then a gap, and then our veneer of brick on the outside. Reverse brick veneer flips that all around. Has the timber frame, our structural frame on the outside, timber or steel, our structural frame on the outside, then a gap and some insulation, and then the masonry or the high thermal mass material on the inside of the wall. So these internal walls in that scenario are the high thermal mass component, and then the insulation and the shielding happens on the outside. The reason that is a fantastic idea is because we want that regulation of temperature inside. We want to have it's good to have a relatively flat temperature within the house, not one that gets really hot in summer and really cold in winter. But
that wouldn't be the best idea on the western wall, though, would it? Because if you're getting a heat transfer through the cladding,
yeah,
a certain amount's going to go through the insulation into that block wall. Obviously, if it's a western wall, it's going to, in summer, it's going to be a lot hotter to dissipate heat into the house.
Exactly. So what you might do with your western wall there, because this is your actual structure here, you might decide not to have that thermal mass on that western wall, and maybe you double stud. So two studs and then more insulation on that western wall where that insulation is required. That might probably even a better approach. And it's about understanding how these concepts apply, but it's all case specific. That what's good for the northern, southern, and eastern walls is not necessarily good for the western wall as well.
Is this all changing? Because when you look at building a house on site, it's got to be the dumbest thing out because you're exposed to the weather and the conditions. And the Germans have got it, the Japanese have got it, that they build their houses in a modular system in the factory.
Yeah.
So they used completely different materials with the compressed foam, walls and everything else like that. And we're looking at stuff that's most probably going to be out of date by the time we get into our graduation period.
Well, yeah, that is a completely valid point, and I'd certainly agree with you on that. But to say it'll be out of date by the time you graduate, I think is certainly a stretch, because and this is one thing about building and design, is that it can be conservative, and things can take a very long time to change, and you think that is a really dumb way of doing it. Why do we do it? I don't know, because we've always done it. And yeah, certainly I think it's fantastic to push the envelope to be at that forefront, and particularly if you can use construction techniques and materials that mean you produce a better thing at a better price and make people happy. That's what ultimately what you want to achieve. Regardless of all that, it is still important to understand the things that are being done now and what has gone before us. Because it's one of those things, you never know what you're going to need to know about the past and what has been done before and why and what is actually relevant. I think really good case in point, so there's buildings in Iran, 1,000 years old, 1,500 years old or so, right? They were using completely passive, energy efficient design 1,500 years ago that is still completely relevant today. But when we, as a species, invented electricity and air conditioning and so on, we thought, oh, we don't need to do all that work and do that stuff. We can just put an air conditioner on there. There are certain pressures that are making that now no longer viable or the best option, and things that were old, can be new again. So it is important to understand. Certainly you might think, I'm not really interested in brick veneer, so on, but you will still have to know that within the workplace and within the workforce. But did that answer your question fairly well? And so insulation, yes, knowing your various different insulation products and how you can achieve those R values is important. Certainly it's an aspect of saving money. Insulation bats, rule of thumb, got to be much cheaper than your other options. If you can achieve the R values you require with insulation bats, you save money. I think this stuff is actually really cool as well. Certainly for sheds, yes, spend $1,000 or something to buy that stuff and chuck it on your shed. Makes a massive difference. Maybe not in housing because you're putting bats in the walls and whatever, and you can achieve all that. But you know, you've got your air cell insulation. Well, you know, no, to avoid brand names, whatever. But insulation that has reflective foil and little air cells in there that can actually just provide another skin to the building and help attenuate that you know, the too much draft happening in your shed. Yeah, makes a massive difference for a little bit of addition. Also, this the spraying in of recycled paper as well is another, like, very effective in that it goes around all of your ceiling joists, seals everything up really well. Several people I've had discussions with about that stuff don't like it for various different reasons. So it has your detractors as well, but certainly very effective in sealing up gaps, which is important in your insulation. You can insulate a wall thoroughly, and then you have an uninsulated gap here. It can significantly compromise the comfort of your house, and also what's important is not just that comfort, but condensation as well. If we have cold temperatures outside, warm air inside that has a bit of moisture, because we've got a gas heater or something like that, there's moisture put into the air, and we don't have very good insulation, we get condensation happening on our walls. That condensation breeds mold. Certain types of mold are not very healthy. So yeah, so it's not just comfort, it's about the health of the occupants as well. Glazing is, certain pros and cons of glazing. One of the cons is that it transmits heat. Now we can attenuate that by having several layers of glazing, so double glazing, argon filled, so we're not transmitting the heat through there. But still, the best thing is to think about correct orientation and placement of glazing and get those percentages on your building correct to the extent that you can, whilst also achieving the desired outcomes of the building. Right? Building a house on the esplanade, we're probably not going to be putting windows facing north because the view is to the west. But
that's my house.
Yeah, right. So that's not the Lady Bay.
The Lady Bay house has got basically that cube with a roof on it, and it's all windows like that, double glazed, argon filled, low E,
Yeah.
tinted.
Yeah, to achieve. Does it
to
still?
Achieve,
Yeah.
and I didn't achieve.
Didn't achieve. Yeah.
But I've still got it. It's close to 200 grand.
Yeah. But it's that balance between aesthetics and making use of those views and the connection to outside and so on. But yeah, orientation is important. The shading is important. The way that the solar access and how that affects. Now you mentioned low E, tinting, etc., double glazing. So these are all ways that we can make glass perform much better. And that is also incredibly important as designers to understand how we can get glass to perform better in certain aspects to be able to achieve things like this. Because comfort's important, but comfort's not the only thing. And how we feel in the building, how we use that building, how that building interacts with the community and the environment, etc., are all very important factors. Some useful websites: Sustainable Energy SA, Department of, planning, and then your home. So your home is, that's a, what's that?
That's a great site.
Yeah, it's a really good website about building, and also about sustainable aspects of building. Also, yeah, various different things on Learn, some inspiring pictures to, what's that?
So that's a photo of our house I haven't seen.